So I'm Dr. David Richards, and I'm a physics professor at Penn College, and I also teach astronomy in a course called the Science of Spaceflight. When you're designing and building a robot or any type of machine, the physics is crucial because it explains the torque and the work and the energy and the power and the electrical. So it combines all those ideas into one. They recently had a robotics competition on campus here, and I took my kids because they thought it was awesome to see these robots battling each other and sparks flying. And it was interesting as I watched because you could see a lot of physics, the low center of gravity and a simple lever and just a ramp, to be able to flip something up and spinning objects. I mean, if you look at the technology that's involved with the robot, it's all based on basic fundamental principles of motion, force, torque, and energy. And so you can't touch something without it touching you, right? That's Newton's third law. And those things are in constant contact and trying to fling them and trying to break them. And so, yeah, you're in constant action and reaction mode with the BattleBots. I mean, it's a great summary of Newton's three laws of force and motion and inertia. It brings all those ideas into one. And so you can make a prediction on how it should work, but other people are trying to do the same. So it's interesting when they battle because you want to see whose design is going to work the best. Science is built upon a foundation of other people's work and their experiments, and you have to be able to repeat the experiment, you have to be able to verify it and validate the experiment. And that's the power of science, because you can rely on other people's work and you can repeat it. And the history behind that is very fascinating, learning the people that came up with the first experiment on finding the electron charge, or the scientists behind them and their life and time is amazing. It brings it all together. It brings the practical theory along with the people that discovered it and how they discovered it into a bigger theory or a law eventually. Wernher von Braun, who was a famous rocket scientist, when he was a child, he said, I wanted to learn how rockets work, but when he went to the books, it was all math and physics, and he went to his teacher and said, look, I need to know how this works, and he was only in 7th or 8th grade. And students do the same. I have students that are always trying to connect the dots and figure out how the physics relates to their major. Physics is built upon kind of a hierarchy of knowledge, so you have to understand forces to understand work, and you have to understand work to understand energy, and you have to understand energy to understand power. And so you have to start off with basics, and sometimes you want to jump in with the most interesting stuff, the quantum physics and that thing, to really get the students interested. But at the same time, you can't just jump into something without giving them a fundamental, basic understanding of the terms that you're going to use and how it all comes together. Physics is the study of the natural world. It studies how nature works without getting into the living things, living organisms. And it goes to the basic idea of what is the observable universe? How do we know what is out there? And it's not just hypothetical or theoretical constructs of your own opinion. It's based on data and analysis and other people's findings. And so it gets to the core of how people should think about how nature works and not just what they feel. There's basically two things in nature, matter and energy. And so matter is the substance and energy is the driver of that substance. And so physics looks at how those two things interact. And what is matter? Well, matter is the substance that makes up everything. I mean, if you look at the world around you, what is it made of? If you break an object in half and then in half again and half again, is there a limit to how far you can break it down into smaller and smaller pieces? And energy is this nebulous thing that's hard for people to grasp. You can't create or destroy energy. It's always transformed from one form to another to another. So we don't really lose it, it's just converted. There are many people that have tried to invent machines that will give you more workout than you put into it. But it turns out that if you go to this fundamental law, it'll save you a lot of time later, because as far as we know at this point, energy is conserved. You just can transform it, but you can't create or destroy it. And it's that kind of constant transformation of matter and energy that gives us the ability to control it, but also to understand how it all works.
What's the most fun part of this kind of project for you?
Definitely the day of competition. Day of competition. It's going in there and seeing it perform. It's just kind of like that moment where all your hard work pays off, and it's like, I actually did this.
Chloe Cease is a senior at Warrior Run High School in Turbitville, Pennsylvania. She's part of a growing pastime that brings math and science together in a competitive arena: Battle Robots. Robot competitions gained popularity with the BattleBots television program, launched in 2000. Today, students are involved in local, regional, and national bot competitions.
The whole idea of combative robots is not just the event. The event is fun, but the event is the end of the lesson. It's to test what you've built.
Kirk Marshall is a technology education teacher at Bloomsburg Area High School. He founded the Rage in the Cage competition in 2012 so that area teams could compete without the high cost of traveling to faraway competitions. He's witnessed the growth of the sport as well as the learning that takes place with the students that compete.
As soon as you throw that, like, hey, there's gonna be a trophy coming at the end, or you're gonna compete against somebody else, kids get excited. It doesn't really matter who you are. When kids see it as a reward to be smart, now we're rewarding the people that really deserve to be rewarded.
Now we're fighting! Robots, fight!
Combative robot is a robot that has offensive capabilities and defensive capabilities. In this particular case, all the robots weigh 15 pounds or less. And we want to basically inflict all our offensive capabilities into the other machine, whether that means lifting it up off its wheels or possibly hitting it hard enough that parts fly off. All of those are good things. And at the end of the match, which is 3 minutes long, judges either determine who is the most aggressive, the most strategy, and also the most destruction. And adding those scores up, they determine who's the winner. If you are lucky enough, you can knock the opponent out, and the match is over a little bit sooner, which is probably the best way of doing it, because you don't want to leave a decision up to judges. When I was a kid, before I would throw something away, I would tear it apart and then throw the individual pieces away. I'd want to know what made this thing work. The kids don't necessarily have that skill anymore. They're not as involved in actively building and constructing items, sort of in the garage or in the basement. So you have to sort of like break down that boundary that they can do things.
Yeah, that was our spare. I made that to be a spare.
This robotics program really helps them in all academic areas, whether it be communicating, in math and science, because they are applying it while they're building the robot, while they're testing the robot, and pretty much all the way through. The hands-on learning and the problem-solving skills that they're picking up, it's second to none.
I didn't know how to use much of the machines back there, but now I do.
We had to pretty much take this entire bot apart, and we had to remake everything because it was all damaged and messed up from last year.
first time we saw it do anything yet. It's got more power than I thought it did. Yeah.
Last year, the weapon didn't spin as fast. No,
It
this
was
is a lot faster.
last year. It was like 1-to-5 gear ratio, and now it's just 1-to-1, so it spins a lot faster, a lot more inertia. So it's looking a lot better than it did last year.
Warrior Run took sort of a leap of faith. And now they're 7 robots strong, and they're impressive. They're laying down the law out there, and that's cool. I recognize a lot of their faces, and when you see some of the kids competing, and you realize that, hey, I saw them when she was a 6th grader, and now she's in, in high school. That's fun.
I would have to say, from experience, about 50% of it is your design and your actual bot. The other 50% is the actual driver and the maneuvering and everything. I mean, you can't go in there, you could have the best bot in the world, but if it just sits there in the center, it has its weaknesses. Every bot has a weakness, and if you can figure out how to exploit your opponent's weakness, you will win. It's all about strategy, being able to maneuver, being comfortable with your bot. You can't go in there and be afraid, oh, I don't want to do this, I could get torn up, I could get smashed. You just need to go in there 100% and hope you come out on top.
If you have a student that is really well versed in physics, they have a definite advantage in designing. So it is just a great opportunity to tie physics and the real world together.
It's interesting when they battle because you want to see whose design's best. But it does come down to the design and the physics behind the design.